and emphysema. And what some people don't realize is that ozone also, when in contact with leaves and crops, can also damage crops as well as cause issues with human health. So where does the ozone come from? So there is some ozone that actually comes down from the stratosphere. That's actually some ozone in the troposphere comes from the stratosphere. But the major reaction, or pretty much the only reaction that we know of that produces ozone, is a reaction that involves an atom of oxygen and a molecule of oxygen. So a molecule of oxygen is O2, and an atom of oxygen is O, and when they collide with one another, they can produce ozone, which is O3. So in the troposphere, where does that oxygen come from? Well, it comes from nitrogen oxide. So nitrogen oxides, there's two of them that we look at, NO2, nitrogen dioxide, and NO, nitrogen monoxide. And when sunlight strikes nitrogen dioxide, it breaks off an oxygen atom. That oxygen atom then combines with our oxygen molecule, O2, to produce ozone. Now, when that ozone floats around, it actually can collide with an NO molecule, and ozone is destroyed, and we get our oxygen back and our NO2 back. So it's a cycle in which sunlight strikes the NO2, produces an oxygen atom, that goes on to produce ozone. Ozone reacts again with the nitrogen monoxide, produces NO2 again. And if this were all that were taking place in the atmosphere, ozone levels would be fairly low. The problem is that there are other things in the atmosphere, some of them emitted by human activity and some of them emitted by, as I mentioned earlier, trees. So volatile organic compounds kind of change this cycle. So we still have sunlight striking our NO2 molecule, and we're still making ozone. But these volatile organic compounds react with things in the atmosphere to produce radicals, and you might have heard of free radicals before. Those radicals actually react with the nitrogen monoxide, taking it out of the equation. Now the nitrogen monoxide isn't reacting with the ozone to destroy it. So the ozone starts to build up. As the VOCs react with the nitrogen oxide, we get more and more and more ozone. So we get this daily cycle. So here's some data from Riverside, California on what ozone looks like every day. And you can see that in the morning, the sun comes up, people drive their cars, power plants start to operate, we have nitrogen oxides in the air, it reacts with the sunlight, it starts to produce ozone. Those volatile organic compounds are out there. They come from plants, they come from gasoline. That's why if you've been to California or to a big city before, when you fill up your gas tank, there's that big thing on the end of the pump that makes sure that none of that gasoline comes out, because we don't want these volatile organic compounds to come out and help exacerbate the ozone concentrations. So it goes up and down because at night you don't have any sunlight. So there's no way to form those ozone molecules. The nitrogen dioxide isn't reacting with sunlight anymore. So what's the situation in Wisconsin? So the National Ambient Air Quality Standard for ozone for 8-hour average is 75 parts per billion. And we tend to have problems, believe it or not, in the summertime, right? In the wintertime, sun doesn't shine so much, so we don't have so much ozone. But in the summertime, we do. And we seem to have problems along the lakeshore. Can anybody guess why ozone is highest along the lakeshore?
Chicago.
What's that?
Chicago.
Chicago. But Sheboygan County seems to be a big problem. That's pretty far from Chicago. What's that? Coal plants? That's a good guess. So we do produce plenty of nitrogen oxides. But the reason why is the same reason why you get more of a sunburn when you're out fishing than you are when you're out hiking. How much sunlight do you get when you're on the boat on the water? You get twice as much, right? You get the stuff coming down and the stuff reflecting up. So that nitrogen oxides and the VOCs from everything along the lakeshore kind of tend to drift out, okay, over the lake. And there's actually more light that can actually hit our molecules, our nitrogen dioxide molecules, and the ozone tends to be greater along the lakeshore. And so what I've got here in red are those counties that are right now in violation of the National Ambient Air Quality Standard for ozone. Okay? Now, it's getting better. The DNR is actually doing a pretty good job of managing this, but we still have some issues here where the ozone levels are higher than we'd like to be. So Sheboygan County there, 81 parts per billion, they're in violation right now. So the EPA calls that a non-attainment. That's a non-attainment county for ozone. Now the other two counties there that are at 77, those are not declared non-attainment yet because these are sort of recent average readings that are there. So the EPA will probably get a letter from the DNR. The DNR will probably say something like, we've got this under control. You don't have to make this a non-attainment zone. Here are the things we're doing to manage the ozone, but they're areas of concern. Okay? So that's where we sit. And this actually is probably, you know, the biggest issue that we're having right now in Wisconsin in terms of air quality is ozone along those lakeshore counties. We're actually doing pretty well in some of these other areas. So the other big issue that we have in Wisconsin is particulates. And so in Wisconsin we have 2 seasons, right? We have winter and we have construction season. In air quality terms, we have 2 seasons. We have summer, which is ozone season. We have winter, that's particulate season. And again, it's because of those inversion layers that we have issues with particulates. And so particles can be directly emitted into the air. So you've probably seen black smoke that comes out of a diesel engine. Those are particles. You see white smoke sometimes coming out of one of those smoking vehicles. Those tend to be organic molecules that are coming out. So we can emit them directly in the air, but we can also form them in the air. So there's a number of different chemical reactions that actually form these solid particles in the air. And those, believe it or not, tend to be most of the particles that are in the air in Wisconsin. Tend to not be the ones that are directly emitted, but the ones that are created in the air. And guess what is the problem chemical for creating a lot of those? It's those pesky nitrogen oxides. So the nitrogen oxides are problems not only in terms of ozone, but they also help create a lot of particulate in the air as well. So nitrogen oxides and sulfur oxides react with oxygen in the presence of water in the atmosphere, so clouds and fog water, and we can produce nitric acid and sulfuric acid. So those nitrogen oxides and sulfur oxides are producing essentially acid rain. That's one way that those nitrogen oxides and sulfur oxides get out of the atmosphere. They rain out as acid rain. But the other issue that we have is this ammonia from our dairy herds. And when the ammonia gets up there in this cloud and fog water in the presence of sulfuric acid and nitric acid coming from the nitrogen oxides, it actually reacts to form ammonium nitrate and ammonium sulfate, which is actually condensed. They're solids. They're solid particles that get formed in this reaction. So those particles actually tend to be, and we'll see some data here in a few minutes, they tend to be the large part of the particulate that we see in Wisconsin in the wintertime, especially the nitrate particles. So we can also have VOCs. These VOCs in the atmosphere can also react to produce organic compounds that are particulates in the atmosphere as well. So I like to tell people that particulates are kind of like snowflakes. Each one is different. So you can't go out there in the atmosphere and grab yourself a particle of ammonium nitrate, ammonium sulfate over here. In that particle, there's probably organics, there's nitrates, there's sulfates, there might be metals, there might be soot. Each one is kind of like a snowflake. It's completely different. So the particles that we're most concerned with are the smallest particles. And so the size ranges are called PM10 and PM2.5. And so PM10 are all the particles that are 10 microns in size or smaller. PM2.5 are the particles that are 2.5 microns and smaller. So a grain of beach sand might be about 90 microns, and your PM10 there, compared to the human hair, which is 50 to 70 microns, those are the blue dots. And then the inset there with the little red dots, that's the PM2.5. So these are tiny, tiny little particles. And the problem with tiny particles is they tend not to behave like particles at all. They tend to behave like gas molecules. Gravity doesn't have too much effect on them. And that's sort of the problem from a health perspective. So when particles enter your mouth and your nose, the bigger particles tend to have a lot of inertia. They have more mass. and they'll stick in the back of your throat. But those smaller particles, they actually will follow the gas stream of your breath down into your lungs. And they're small enough that they actually get into the alveoli. Now, the alveoli is kind of where the rubber meets the road for your respiratory system. That's where things, if you're a smoker, that's the nicotine delivery system. When you breathe that smoke in, that nicotine goes down the alveoli, and then it can get into your bloodstream, okay? So these particles are essentially a toxic delivery system. So anything that's in the particles can potentially get into your bloodstream. So if it contains some metals, if it contains organic compounds that might be carcinogens, this is the delivery system for those things. We also know that these particles tend to cause inflammation. They cause something called oxidative stress. So one of the reasons why your COPD probably acted up today is that your body was fighting off those particles. And so you got some inflammation. And because you have that inflammation, it makes it hard to breathe. You have difficulties, okay? And so that's what the particles are there kind of doing. The presence of those particles kind of inflames your lung tissues. And it's because they're so small and can go so deep in your lungs. So just to give you an idea of sort of what the health consequences can be. So if we take a healthy rat, and laboratory rats are notorious tough creatures, okay? They survive a lot of insult. And if we inoculate the lungs of a laboratory rat with listeria, a nice healthy rat, the rat will develop immunity to the listeria and just keep on ticking. But if we take a rat and we expose it to particulates from, let's say, a diesel engine, and then we inoculate the rat with listeria, the rats don't do so well, okay? So this is this idea that it really offends the immune system. It causes issues with the immune system, ours and obviously the rats as well. So there is a wealth of evidence out there of the health effects of particle pollution. One of the most famous studies that's out there was done by the Harvard School of Health. It's called the 6 City Studies. And the background city, the one that had the cleanest air, was Portage, Wisconsin. And so they went and they measured all the particulates over the course of a year or more at all of these different sites, and they tracked mortality and morbidity. So they came up with this formula that said hospital admissions and deaths from cardiovascular insult and other issues, how does that relate to the concentration of particles in the air? And they found a very strong correlation between the concentration of those little tiny particles and those hospital admissions and deaths. So that has been sort of the study that everyone's hung their hat on, and since then there have been literally hundreds of studies that have supported this idea as well. So how are we doing in Wisconsin on particulates? So actually we're doing pretty well. So the 24-hour standard is 35 micrograms of particles per cubic meter of air, and we're actually under that limit for every county right now, according to the EPA. Now the red down here in Milwaukee County is because they are technically still in violation of the ambient air quality standard for the measurements that were made a number of years ago. And so there's a process that the DNR has to go through in order to get that out of sort of the non-attainment is what it's called. And so they're in that process. That letter has been sent to the EPA, and happily it looks like air quality as far as particulates are concerned is getting better in Wisconsin. It's in pretty good shape. Now, how much that has to do with the amount of manufacturing that we have in Wisconsin anymore, I'm not sure. So we'll have to see what happens when the economy starts to bounce back. If we get more manufacturing in here, then we might have some more problems. But as of right now, things look pretty well. The other thing that I was concerned about when I was looking up these statistics is that in December, the EPA actually lowered the standard for annual particulate concentrations. And they lowered it down to 12 micrograms per cubic meter, and I thought for sure that we'd have some problems. But it turns out that the annual standards are being met everywhere as well. So it's generally a good story when it comes to air quality in terms of particulates in Wisconsin. So the last thing I want to talk to you about tonight is an air quality study that my students and I did in the town of Grand Rapids, not this past winter, but the winter before. And so we received some money from an organization called the Lake Michigan Air Directors Consortium. Now LADCO is really just that. It's a consortium of the air quality directors for states around Lake Michigan. So Minnesota, Michigan, Wisconsin, Ohio, Illinois, Indiana. So they contribute money towards this organization to help them figure out air quality issues. And so they support research like the research that we did, because sometimes, as we know, these state agencies don't have big budgets and they're not able to launch some of these experiments on their own. So this was a non-regulatory study, so we weren't out there trying to tell people that they couldn't burn wood. We were not out there trying to tell anybody that we were going to regulate their wood burning. It was just, we wanted to know, and the Great Lakes states wanted to know, what's the potential impact of wood smoke on air quality? So I guess that begs the first question, is wood smoke harmful to your health? And the answer is that lots of studies have said yes, and a lot of folks have been surprised by this because they love the smell of wood smoke. And they think, oh, wood smoke, you know, it can't harm me, it smells good, it reminds me of Christmas and of campfires and all those kinds of things. But wood smoke does contain some things that are hazardous. It contains particulate matter, fine particulate matter. Carbon monoxide, methane, organic compounds, trace metals, all these things are there. And so breathing a lot of wood smoke is generally not considered to be good for your health. What's driven sort of this interest in wood smoke is the rise in popularity of outdoor wood boilers. So in terms of the growth in sales of these OWB units, Wisconsin is second only to Michigan in terms of the growth in the last decade and a half. So we're selling more of these things. People are using more and more of them as primary sources of heat, even as sources of hot water for their homes. And so the town of Grand Rapids was really interested. They knew that they had about 50 of these things in the town, and they wanted to know what's the effect on our local air quality. And so what we did is we set up 3 different air quality monitoring sites. And it kind of went around a north-south transect here. So we have this southern study site, the central study site that was at Town Hall, and then a northern study site. And then we plotted out a couple of different routes for us to drive a vehicle around. And so, I have to walk in front of this again. We had some little monitors like this. So this is actually a personal particulate monitor, and you can wear it on your belt. And we used them in heated boxes in our study sites, and we also put them in a vehicle to drive around. And I'm just gonna, we'll turn this on a second, I'll pass it around, and you can measure the air quality as we finish the talk here tonight. It'll take just a second to kick in. The readings that you'll see on the front are in micrograms per cubic meter, so the same measurements we showed on the map of Wisconsin. So we did this study for 3 months, December, January, and February. We took samples every day, we took readings every day, and in January, during 8 evenings, we drove around these neighborhoods to try to see what the air quality was like. So this is our primary monitoring site. I have to thank the Wisconsin DNR. This is really what an air quality monitoring site looks like in Wisconsin, because this used to be the air quality monitoring site in Madison. So when I was a grad student there, they told me that they were getting a new trailer, and I said, I'm going to Stevens Point. Would you like to give me the